Okay, for question 7, it gives you, that's the integral, and it says to use that. Okay. It says find the integral using substitution. Okay, so what we're going to do, I'm going to solve for sine. So I'm going to have x over 2 equals to sine of theta. And based on this, I'm going to do a triangle. So sine is opposite over hypotenuse. So I need to find this side using a squared plus b squared equals c squared. So then this side is going to be 4 minus x squared. Okay. We also, given that x is equal to 2 sine theta, we also need to find the derivative, which will be dx equal to derivative of sine is cosine. So it'll be 2 cosine theta d theta. I'm going to use this to rewrite our integral. The way I'm going to rewrite my integral, I'm going to have the integral. This right here is a ratio for trigonometric functions. This is this one right here, which is the adjacent, and this is my opposite. Adjacent over opposite is cotangent. So I got cotangent of theta. And then we have dx. Well, my dx is 2 cosine of theta d theta. The 2 is just a constant that I can factor out. Cotangent can be rewritten as cosine over sine. I multiply cosine times cosine and we get cosine squared. Okay, I'm going to use the same function I used earlier from pre-calc. Sine squared plus cosine squared equals 1. I need to solve for cosine. So cosine squared theta equals 1 minus sine squared theta. Why am I doing this? To write everything in terms of sine, so that I only have sine. So then I have 1 minus sine squared theta over sine. But now I have 2 terms in the numerator, and I can separate it and make 2 fractions. So I can rewrite it. 1 over sine is cosecant. Sine squared over sine, one of those signs cancel, and now I have sine of theta. The integral of cosecant, with the parentheses, is negative ln cosecant of theta plus cotangent of theta. The integral of sine is negative cotangent, so the negative cosine negative cosine. So negative and negative becomes positive cosine. But remember that we did not start it with sine and cosine. We started with x. So now I need to go back to my triangle and find cosecant, cotangent, and cosine. I'm going to have 2 negative ln. So cosecant, remember, what is cosecant? Cosecant will be hypotenuse over opposite. So 2 over x. Cotangent will be adjacent over opposite. I'll show you right now, right there. Cosine is adjacent over hypotenuse. And that's my final answer. Okay, number 8 is super similar. So this is a function, and it says use x equals 5 tangent of theta. So just like on the other one, I'm going to divide by 5 and have the tangent of theta. I'm going to create my right triangle. Tangent is opposite over adjacent. So to find the hypotenuse will be x squared plus 25, or the square root of x squared plus 5 squared, which is 25. This order doesn't matter since we have a plus sign. It could also be 25 plus x squared. It does not matter. So now let's see. Got that. Remember that x is equal to 5 tangent of theta. I gotta find the derivative. And so the derivative is 5 secant square theta d theta. And let's see. So x over 5 is tangent. Okay, I'm gonna need to figure out a way to find or to use this one. Okay, so this is what we're gonna do. I'm gonna find secant of theta. Secants are reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So I'm gonna multiply the 5 to solve for the square root. Okay, so now let's substitute it into my formula to do the integral. Okay, so I got the integral. Remember, x over 5, it's tangent. This one right here, it's 5 secant dx. dx is 5 secant square theta theta. 5 times 5 is 25. I'm going to factor out that. I'm going to leave everything else. Tangent, secant, and secant squared of theta. Now I'm going to do a u substitution. I'm going to let u be secant of theta. So then the derivative of secant is secant tangent. It doesn't matter since we're multiplying if I have secant tangent or tangent secant, which I have it right there, d theta. So if I substitute that, I'll get 25 u squared du. To do the integral, I'm going to add 1 and divide by it. Remember, plus u. But u is not u. In this case, u was secant of theta. So I got 25 secant of theta to the third power over 3. But again, secant was not just secant. Now I need to, because now this is in terms of theta. The original problem was in terms of x. Well, I do have secant of theta already right here. So my final answer will be 25 square root of x squared plus 25 over 5 to the third power. All of that is secant. That 3 right there, I'm going to move it with the 25. Because the 3 is not inside the cubed. Plus c. And number 9 says to use partial fractions. So the first thing we do with partial fractions, we look at the denominator and see how we can factor it. This is a difference of squares. So we have x plus 6 and x minus 6. So what we're going to do, we're going to put this one. It's a linear, so I'll put an a on the numerator. For this one's also a linear. I'm going to put a b in the numerator. How do I have fractions? We have common denominators. So for this side, I need to multiply the x minus the 6. And to this side, I need to multiply the x plus the 6. Okay, so then I'll have ax minus 6a plus bx plus 6b. Let's figure out what's a and b. So let's look at a constant. Our constants, we have negative 6a plus 6b, and then we look at the numerator of the original problem, and there's a 1. Then I look at my x's. I have a plus b, and there's no x in the numerator, so that's going to be equal to 0. Let's solve for a and b. So what I'm going to do, I'm going to multiply the second equation by 6. We have negative 6a plus 6b equal to 1. 6a plus 6b equal to 0. That cancels out. We have 6, 6. And so what I need to do, I need to divide by 12. And so to solve for a, I need to plug it in. It could be either or these two equations. I'm going to plug it into this one. So then a equals, if I move b to the other, so it'll be negative b. So a equals negative 1 over 12. So then I'm going to rewrite my integral. Okay, I'm going to rewrite my integral. My integral will now be x plus 6, and it's a. A is negative 1 over 12. Since it's just a constant, I can move that outside. Plus b. B is positive 1, 6. I can do another integral right here. And I could put 1 over 12 and also take it out. Okay. And now I integrate this right here. I'm going to use a u substitution. I'm going to lay u b x plus 6 for this case. The derivative would just be 1 dx. So then we have the integral 1 over u du, which will be natural log. So we have negative 1 over 12. Natural log of u, but remember that u is not u, is x plus 6. I'm going to use similar method. I'm going to use the u equals x minus 6. My du will be dx. So then I have 1 over 12, integral of 1 over u du. So now I have 1 over 12 ln of x minus 6 plus c. Okay, so we have partial fractions again. So let's factor my denominator again. So 1 multiplies negative 5, that when you add it, you get positive 4. So it's going to be positive 5 and negative 1. They're both linear, so I'm going to put a and b on the top. So this one's missing the x minus 1, x 5. So we're going to distribute. I have a x minus a plus bx plus 5b. Okay, let's group them now. Constants, I have negative a plus 5b, and in this case on the numerator I have a 6. Where are my x's? I have a plus b, and if you notice up here, there's no x, so 0. So, just like I did in the other one, I'm going to multiply this one times the negative 1 in this case. So I got negative a plus 5b equals 6. Oh, you know what? Do not need to multiply times anything. Let's ignore this. We got a plus b equals 0 because they're already opposite signs. Let's just add them. So those two cancel, and then I get 6b equal to 6. And when we divide by 6 on both sides, I get b equals 1. A plus 1 equal to 0. Solve for a, and a is negative 1. let's substitute it.